Right. Very good afternoon to everyone. Can you hear my voice? I'm the MC for today. If you can hear my voice, can you type one in the chat box? Right. Okay. So I think it's about time. 3:05. I think we can start with a brief introduction to our PLS speaker today, Prof. IR Dr. Malathy. So, Prof. IR Dr. Malathy actually obtained her master and PhD degree in engineering from the University of Malaya, Malaysia. Her research expertise lies in the field of laser, fiber optic sensor, and also plasmonic sensor. She actively served as a reviewer for multiple journals and also the committee members of the Optical Society of Malaysia. In addition, she holds a position of managing editor for the Journal of Innovations and Technology. Prof. Malathy also a registered professional engineer with the Board of Engineers Malaysia and also a chartered engineer with the IET UK. Besides, she holds several key leadership positions, including the director of the Center for Data Science and Sustainable Technologies, chair of the University Research Committee, and also the chief internal auditor for the Malaysia Research Assessment at the Indy International University. Right. So we are very uh, thankful that Prof. Dr. Malathy can spend her precious time with us to give us this IEEE My Malaysian chapter for the photonics lectures series. So I would like to pass the time to Prof. Malathy for her seminar.
Thank you very much, Mr. Chu. So I would like to confirm with the audience if you are able to view my slide.
Yeah, but the slide is not in the presentation mode yet.
Now, is it okay?
Yeah, now everything looks okay.
All right, so very good. Thank you. Okay, so I'm Malathy Batumalay. Currently, I'm attached to Indy International University. So today, right, I'm going to share with every one of you on a topic of machine learning algorithms for SPR. Slide is moving. Okay, machine learning algorithm for SPR biodetection application. I have done a short review on this, so that will be my sharing session with you all this afternoon. Okay, that's a little bit about myself because I saw at INTI IU, Malaysia, and I have obtained my PhD from University Malaya, and my research area was photonics engineering. Okay. Before I move on into my topic today, I would like to share with every one of you a little bit about why am I moving into machine learning. So the main reason is that we are now sitting in fourth industrial revolution, IR 4.0, and this industrial 4.0 is referring to the industrial revolution, which integrates advanced technologies such as AI, big data, analytic, Internet of Things, cloud computing, robotics, cyber, physical systems, which are very important to optimize and automate the industrial processes. So the main reason is it is characterized by smart factories. Everything today, if you see, is smart. Okay. Even we have autonomous decision making and all the systems are decentralized. So it all happens because of IR 4.0. So there is a main pillar for this IR 4.0, and these main pillars includes technology, people, and process. So when we talk about technology, right, everything is moving into robotics. Robotics is referring to machines which are able to perform any task that was traditionally done by human being. On top of that, we have machines and technologies which support, for example, designs such as 3D printing. Why do we have 3D printing? Because we are creating products or models or even prototype which can later on be implemented into a final real product. And on top of it, we can see that we hear a lot about big data. What is big data? Big data means analysis of a very huge amount of data which is able to provide solution to design smart solution. So today you can see there's a very huge diverse in the area of medicine, agriculture, gambling, environmental protection, and so on. Okay, so all these are reflecting to one of the main pillar of IR 4.0, which is technology. On top of that, we can see that people who are working around IR 4.0 are expected to increase their efficiency, because you can see the amount of physical labor connection have been reduced. So to stay in this, to stay in this era, right, we should actually develop our skill from time to time. Okay, because things are already autonomous and we are actually playing our role only as a monitor for the entire system. And the third pillar of the IR 4.0 is the process. What does this process reflect to? It is reflecting to communication between machines. And these machines are decentralized and it is able to produce smart system and decision making. So we can see that with the three pillars, as I mentioned just now, people, second thing is technology and process, it will reflect to industry 4.0. Okay, why do we need IR 4.0? Because we need to have digitally skilled workforce which is able to incorporate AI and also IoT system. So when we are able to come out with this kind of infrastructure, we need the requirement for something called 5G platform, cloud platform, to support the advancement in networking. And on top of this comes cyber security, which protect the interconnected system. So when there is interoperability between various machine software and data format, we need to have a proper system and we must be able to adapt the new innovation. Okay, now, second point that I want to highlight here is about SDGs. Okay, now, everything that we are doing in research should reflect to sustainable development goal, which is an aim for the nation to be achieved by the year 2030, where all people can enjoy peace and prosperity. Okay, so this is something very important. No matter whatever area of research that we are doing, we have to ensure that our research work is actually reflecting to one of the sustainable development goal. Okay, now coming to our topic today. All right, now we have started with telecommunications, right? Okay, in telecommunication, that means involve sending and propagating of analog or digital information. And to send this information, we are using physical point-to-point or multi-point transmission. It could be wired, it could be wireless. So this is how transmission have started. So when people are doing transmission, it is involving packets of data, phone calls, emails, and so on. Okay, now our research work that we have actually started 10, 12 years ago, right, was focusing on optical fiber. So from transmission, okay, imagine that we have moved transmission into sensors, okay. So how does this ideas came to us is that we found that optical fiber was something that is very flexible and it was a very good transmission medium that we can use to send information from one end to another end. So at that point of time, actually, our aim was communication. But what my team did at that time was to convert a fiber which was used to carry light into something that we call as we call it as a what we call we were using a technique called total internal reflections. Okay, we were working on that. We converted, we studied, first of all, we studied the physical characteristics of a fiber. And in this optical fiber, right, we found that there is two elements, okay, core and cladding layer. And the light is kept within the core of the fiber when there is a phenomena called total internal reflection. And this was due to the refractive index difference between the core and the cladding. So that is how we started the research work. So you can see in this diagram, it's showing how does where does a core sits and where is the cladding, and how does the light is kept inside the core, and this phenomena is called as total internal reflection. I'm not going to go into this because this is very basic. Okay, now at that point of time, we were also working on this system, knowing that fiber optic was replacing the copper cables, okay, due to several reasons that you can read on this slide. Okay, the first thing was it was at that time fiber optic was a common alternative, and it could travel for a longer distance, and it carries a higher bandwidth with faster speed, and also it was able to withstand the electromagnetic interference and the signal losses. Okay, these are the advantage of fiber optics, if you can see. Okay, now moving into our research work at that time, as I mentioned just now, we were working on something called total internal reflection. In optics, right, we have something called evanescent wave. Okay, evanescent wave are formed when the wave that is traveling in a medium undergoes a phenomena called total internal reflection. This happens at its boundary when the incident angle is greater than the critical angle. So evanescent waves are made of electromagnetic energy that cannot propagate or sustain a resonance. So what happens is that it will decay exponentially from the point of the boundary where it is created. So there was two conditions for total internal reflections to occur. The first thing, the light must be traveling from a more dense medium into a less dense medium. And also there is another condition, is that the angle of incident must be greater than the critical angle. So we studied this pattern first. And slowly we started moving into what we call as people were working on silica fiber. At that time, we transferred to plastic fiber. What I'm telling you is in the year of 2012, somewhere around there. Okay, we studied the evanescent wave phenomena, right? Okay, we understand that the total amount of electro evanescent wave is directly proportional with the reflection of light, and there were a measurement that can be taken due to modulation of light. So what we did, we apply this concept into monitoring humidity, because monitoring humidity was very important issue in various area of application, such as we can say instrumentation, automation system, even in agriculture. So we developed a very simple relative humidity sensor that you can see here, which was actually proposed by employing tapered plastic optical fiber, POF, which was later coated with zinc oxide nanorods that were grown using hydrothermal methods. So this tapering of plastic optical fiber is done using chemical etching. Okay, chemical etching method. And to enhance the performance of plastic of optical fiber as a sensor, a certain length of the fiber need to be tapered. So what happened is that the amount of evanescent wave was increasing with the increasing reflection of light with the sample of the tapered fiber. This was actually collected. And at that time, we were focusing on zinc oxide, right? Which also provide a high surface to volume ratio because this particular tapering system was able to absorb more water that changes the Ri and the modulation of light. So the reflective index of zinc oxide was observed to be higher than the core, which actually changed the fiber to become a lossy waveguide. But that was good for us because we were actually investigating on a sensor method. Okay, I'll move on to my next slide. So you can see here, our direction was at that time we were working on tempered plastic optical. Sorry? Okay, all right. I'll just continue. So after some times, our pattern changed where we start working on surface plasma resonance SPR. And this SPR sensor was actually utilized to detect the change of refractive index as well. So you can see SPR is very famous in biology, chemistry, even for environmental monitoring. This kind of sensor could provide an extraordinary sensitivity based on the SPR or localized SPR, we call effects that you can find in many commercial application that I can actually show in the diagram. Okay, but there is something that can add, a unique optical property was the coating. Okay, what we can do. So right here, we were actually studying on nanoparticles, which was used as an absorption and scattering light extraordinary efficiency method here. So we found out that there was an interaction between the photon lights and the electron metal, which provide a collective oscillation at a specific wavelength. So this kind of SPR fiber sensor can be used as sensor to measure strain, temperature, pressure, and so on. Okay, all right. So using this method of SPR, we have developed, okay, these are the research work that we have done. Among it is a plasmonic sensor, which is used for relative humidity. This plasmonic sensor is the interaction of light with materials to be sensed at the interface between the metal and also the dielectric insensing process, which is able to cope with the requirement very well, can be observed. So this plasmonic sensor was a study of interaction of light with the material that we want to sense at the interface between metal and a dielectric. So in this case, right, to study relative humidity, we used graphene oxide as a selective layer, and we are able to observe the changes that you can see in the graph below. Okay, now, so this graphene oxide in cooperation with gold-coated setup was further developed in a very compact relative humidity sensor. On another research work, okay, this plasmonic sensor was used for food safety. Okay, we have presented a paper on this. And in this research work, right, it was a combination of graphene with a gold-coated Crashman SPR sensor for sodium nitrate detection, because sodium nitrate is one of an important factor for food safety. So it was used to detect the presence of and the amount of sodium nitrate. So we found that the SPR light energy was coupling with the interaction occur between the photon light and the electron of the metal. It was used to sense various analyte solution. And the reason why we selected gold was because it was a plasmonic material that gives SPR signal a convenient combination of reflectance angle and also wavelength. Okay, further to this, we have also did some research work to study on the SPR resonance for gas sensing. But the challenge that we faced here was that how are we going to, control the presence of gas, and we were also having some difficulty on monitoring the system in the presence of the volume of gas. It was because we were actually more concerned about the safety of the researcher during the development of this sensor. So even though the aim of the project is to develop an optical sensor for rapid, accurate, and even cost efficient detection, but there was a lot of gap that we need to fill in actually to obtain the results that we wanted. So that was the challenge that we faced. So to further investigate on how can we overcome this method, so there was a lot of literature study that I have actually conducted, and one of that was using machine learning algorithm for SPR, which can be used for biodetection application. But it is currently at the level of investigation that you can see, and I'm going to present about this. So what we observe is that using SPR, it is able to detect toxic gas, water pollutants, even biomarkers for many diseases. So now, when we are dealing with the detection of these kind of areas, safety is a concern. Okay, so we know that SPR is a good candidate for future what we call sensing platform because it is able to give us high sensitivity. However, when we look at the cost, what are the cross sensitivity and the how are we going to handle large amount of generated data? That was something that I think we have to look back and think about before moving into the research. So what was the solution for this problem was using machine learning algorithm which can address to these challenges. So when we talk about machine learning, that means we are reflecting to AI and ML with SPR sensing mechanism. So here I'm going to present to you a short review that I have collected which can help to solve the challenges faced by traditional SPR. So now let's look at this. Okay, using SPR sensing principle, okay, we understand that it's actually the effect of coupling of photon energy, okay, with the plasmon of metal dielectric surface. SPR occur due to coherent oscillation of electrons in a metal dielectric. So if you want to enhance the performance, we can coat this with a minimum, okay, with a thin 45 to 70 nanometer metal layer, which could be gold, silver, or aluminium. And we are able to look at the propagation constant of the plasmon, which is shown in the slide that you can see. Okay, so this SPR integration method for biodetection application can be found where it helps to actually locate the wavelength at which point does SPR occur. And these SPR sensors using selective coating material, like I mentioned just now, it will be able to bind when the analytic medium have been tested. So it helps to detect the refractive index of the metal dielectric layer, which increases, and it helps to perform in a way that we will be able to see the resonance dip experience a shift. Okay, this wavelength with the presence of analyte are able to map into sensogram, which are simple response curve, and it can make readable to state the analyte presence and also the sensing process kinetics. So this integration is a similar process that is used as a monochromatic light source. And the resonance angle is one of the experience of shift in the analyte presence. Among the studies that we have conducted and presented into papers is, for example, is the research on SPR which has been used to build dengue virus sensor. Okay, for instance, it is able to show a very good sensitivity. On another case, it was also showing the level of antibiotics and how does the sensitivity response within the detection of time of 15 minutes. So we can see that SPR resonance sensor is suitable for biodetection applications. So using SPR instrument, we observe that it is actually very bulky and expensive. And these standard sensing signal are actually used for example resonance, angle, reflection, intensity, wavelength, and also changes in phases. So angles and wavelength resonance change are important in most common signal, but these methods are expensive if we look at using spectrometers or even rotating stage. So we need to look for a different, more cost-effective method. And one of the method that we can see is using machine learning algorithm. Okay. Now, how does machine learning incorporates into this smart device? Okay, we have to see that using the data that we have collected, right? These smart devices can be built on sensors, okay? And AI as a software is used in most of the factories, hospital, and even houses. So the breakthrough is that using AI and machine learning technology, we can analyze a large amount of data, and this amount of data can be stored into cloud computing and help to make AI powered devices. All right. So a conventional machine learning algorithms can select individual features to achieve a desired performance level. Using the technique of deep neural network, it will be able to generate features which can automatically use during the learning process. So it is important to come out with the DNN algorithm which are performing well in image, even in speech recognition. Okay, so now this smart machine learning can become a backup sensor which can be used for automated monitoring. Okay, it a very complex system behavior. Okay, so this is one of the software that we can use in developing our sensor, and it will actually help to study more on the behavior of the virtual sensors to monitor the parameter that cannot be measured directly by developing collaborative behavior from the available working sensor. All right. So machine learning can definitely enhance the performance of sensors. So using machine learning algorithm, we can actually help process in analyzing big amount of data from a complex sensors matrix, and it can also be obtained from a readable results, and it will be able to separate between the data that is usable from the noisy ones and even from the low resolution sensing data. So machine learning will help you to, clean your data. This is what I'm trying to tell you. Machine learning technique can be used to clean your data and just take the necessary data, which can be used to get a more reliable prediction of output that is required in our research work. So by using machine learning method, we can expose new relations between the analyzed samples parameters and also resulting in collected data from the sensor, which is able to categorize the sensing signal and also detect if there is any biofouling or inference. So this short review is actually aiming to introduce how our machine learning algorithm can be used to improve the performance of SPR biosensor. So I try to repeat the important information here. Using your machine learning, if you have a set of data, a large set of data, you can actually first clean your data. Okay, and you can use the clean data to be analyzed, and the outcome from the clean data can be used to get a better results that is required in our research work. So it will help you to filter the unnecessary volume of data. Okay, now, so with machine learning, it can improve SPR biosensor. How? Because using machine learning, automatically you can reduce the costs. Okay. Second thing, using machine learning algorithm, you are able to process a large amount of data. Okay. All right. No matter whatever data that you want to process. And this machine learning is also able to extract sensing signal from noisy source. Okay. So it will help you to filter. It will also help you to clean your data. Okay. And next, moving forward, using the light source with low power, okay, can be used, which is more safe and more cost effective. Okay, with this, you can have a cross sensitivity to ambient environment. For example, temperature, humidity, and pressure can hinder the SPR sensor. So using ML processors, you can have variant and build multi-parameter sensor that can consider, okay, the ambient environment. So with this, what we achieve? A dynamic response of SPR sensor, which can show the non-linear behavior. Okay, all right. Now, using this machine learning, we are also able to get a more independent output data. Okay, all right. So this is what we can achieve. All right. Recently, what we see, machine learning algorithms are used to optimize coating of plasmonic material, processing the sensogram or other sensing data in SPR. Okay. Machine learning is also used to guide the selection of seed mediated growth to get the desired plasmonic wavelength. For example, for C, like gold nanoparticles, using genetic algorithm. And this is based on a artificial neural network. Other than that, machine learning has also been used to improve the performance of SPR for DNA detection with meta materials. All these are collection of literature that we have found in our research work. On top of that, the reflectance characteristics of meta materials were also used as a prediction using autoencoder with a multi-layer perceptrons. So MLP. So these are all samples. On top of that, we also have clustering facilitated and accelerated design process. And this sensor can improve 13 times better in terms of detection sensitivity over the conventional SPR biosensor. So when we look at the amount of research that have done, okay, that builds our confidence that machine learning is definitely going to improve the SPR biosensor. Okay. However, okay, I would also like to mention here, there are some limitation that we also have to look into. Despite its potential to improve SPR biosensor performance, okay, using machine learning can face some challenges. For example, I give one example here, whether the data sets that we are obtaining is sufficient to support or not our results. Because sometimes when we see if we can't get the right amount of data set or we cannot obtain the enough amount of data set, okay, that is where our challenge will actually start. But however, I believe that SPR sensor, which is designed using ML, can definitely provide some improvement from time to time. Okay, there are many published SPR sensing method which are differ, okay, from each other. However, if the research work continues in this field, we will get a stronger evidence to support the research work that is done. Okay, so we can actually see what are the differences, and we can find what are the evidence that we need to support the improvement of SPR biosensors. So very important here is a global framework for ML powered with SPR biosensor is needed to be considered, which can actually facilitate the adoption of machine learning algorithms. Okay, now as a conclusion, I will say that machine learning can definitely enhance SPR biosensor performance, which will actually help to sort the output signal. It can help us to detect the falling, okay, reduce the effect of noise, and definitely it is going to automate the sensing processes. Using machine learning, we can see that there's a lot of new applications can be seen through this, and using ML into SPR can definitely improve the sensitivity and reliability. So this is the conclusion of using machine learning. On top of this, something important is that we are going to align our research work to something called SDG, right? Okay, now when we do research and we are able to align our research work with SDG, definitely it is going to support the direction of the government, the direction of the organization, and also as an individual, we can contribute to the collective effort to create a more sustainable, okay, and prosperous world. Okay, it is actually providing us with a roadmap to address complex challenges, but it is able to promote a better future for all. And most important, we can drive a positive change and improve the well-being of the people, right? Okay, and through incorporation of machine learning into our sensor, actually we are incorporating machine learning with Internet of Things. Okay, so this is the next direction that we are looking at. So by coming up with ideas which can reflect to AI, IoT, sensors, right? Actually, it is our mind changing things that we can see. We are actually driving a positive change. We are improving our lifestyle as a researcher. Okay, we are adopting the latest technology into our research work. And through the shared responsibility, I believe we can accelerate a progress, and we can actually achieve a better sustainable future for the generation to come. Okay, with that, I think I will end my sharing. If there's any question, I think I will take the question.
Thank you very much, uh, Prof. Malathy. We would like to open the floor for any questions. Okay, I got one question. Prof, can you share
Yes.
with us that what kind of data that should be used to train the machine learning or any deep learning model?
Okay, maybe what we can do at the present, right, with the data that we have with us, okay, we can, like say we have done our research work on humidity sensor, right? I have the data set with me. So that data set can be used to train our model because we already have the output. We can do a comparison and see if it is giving a similar sensitivity. All right, so that is one example. Other than that, maybe we can go to some reliable resources. Okay, we can name it. Okay, some reliable resources which can actually help to train our model. But we have to see whether we need a reference, right? That's why I said first start with the data set that you have with you. Okay, make a comparison. If you already see the pattern and the model is giving the right output that is required, then we can use it to test on other models, I mean, data set that is available. So this will be my suggestion to you. I hope I answered that question.
Okay. Another further question from the previous one.
Yeah.
Among all the machine learning method or the deep learning method has been used, which one do you think that will give the most promising model?
Okay. Uh, we were actually working on just now. If I share correctly with you all, just hold on. I'll go to that particular slide. A minute. Okay, actually, we were using a deep neural network to generate the automotive. I think I've shared that on my slide. We were actually focusing on DNN algorithm, and we found that it is able to even work on images and some kind of recognition, and it provides a very promising results. So this was the technique that we used for our research.
Okay, so it's a deep neural network that customized by the researcher.
Yes, correctly.
All right. So we have questions from the chat box here.
Okay.
Some participant was asking, can the slide been shared with them?
Definitely can.
Yeah. So.
After this presentation, right? I
Mhm,
will share this slide with our MC today.
mhm.
So maybe Mr. Chu, later you can just circulate to them.
Yeah. So
On top of that, right, Mr. Chu, I will also share with you the research paper that we have published on this
okay.
about the
So
short review.
uh,
So on in that paper, right, I have included actually it's a research work that I've done with my student, one of my student. So I have actually given the references that we use for our literature study. So I believe that that could be a good reference that you all can use to start this project at the moment. So now at the moment, right, we are working on more on a biosensor. So when we want to move to from biosensor, we started this work quite some time ago. But when it came to gas sensing, right, it was really very challenging for us. How are we going to monitor the sensor, and how do we know that that environment is safe for us to work or not? That was the challenge that we were facing. So how I discussed it with my student. We came to a us being in that situation, right? Correct or not? At that point of the place, is it safe for us or not? So why don't we move to machine learning? That means collect data, but we have to repeat, right, the experiment for several times. So we were actually worried about the safety of us being at that spot. So that is where we came out with why don't we have ML? Okay, but to have ML, one challenge that you'll face is that whether the set of data is sufficient or not for you to do the analysis. That's the only thing you have to assure first. So what I will say is that once you have obtained your results, right, you will come out with the you will observe the outcome. You test the data using machine learning. Okay. So once you test, and if you can see the similarities, right, between the practical, the experiment that you have conducted and whatever simulation results that you're obtaining, when there is very close observation that you can see, then you will be confident on the set of parameters that you are using for your simulation. So you have to play around with this several times until you obtain the desired, what we call required outcome. This is what we can see here. So it is testing. You have to test for several times until you obtain. So this is normal, right, in research. Do you agree with me, Mr. Chu? What
yes, I
about
think
others? Everyone here. It's
yeah.
a challenge. It is challenge, but yet we have to keep going on this. All
Okay.
right. We
There is another question.
Yeah, sure.
The asked by I think Miss or Dr. Ru Aina. The question is, may I know how much or benchmark of the data to be categorized as enough? to be processed for ML. I think that is referring to the size of the data requirement.
Yes, yes. I really have no answer for this. This is a very good question, I can say. I will say, because first thing I mentioned just now, even though your data size is big, right? Cleaning of the data is the first process that we have to do. The reason is that we want to remove the noise. Okay. You have to make sure your data set is reliable. Okay. Even though your sample size is moderate, right? Not very large, but moderate. But if the sample size is good, okay, you have removed and you have cleaned your data, then I will say that this is reliable for the outcome. All right. So more data is good, but then you have to clean and remove the noise. That's the most important thing. I hope, doctor, I've answered your question. If you have further question, maybe you can just on your mic and speak to me.
Okay, another questions from Miss Intan or Dr. Intan here is,
Yeah.
do you agree that if we hybrid the algorithm model, the results will be better?
Okay, may I know how you want to hybrid the algorithm? Doctor, can you further elaborate on this?
I think if you all can open up your
Yeah.
mic and can you speak to the
Yes,
mic.
yes, yes.
So I think the hybrid algorithm
Are you?
meaning might be using two
Yes, yes.
different ML or DL models. If I not get the
Do you
question
agree
wrong.
if the okay? Dr. Intan, is it? Dr. Intan, have you tested this, Dr. Intan? Oh, okay, okay. Oh, you are a student. Okay, never mind. It's okay. Intan, actually, it's very simple. There are several model, right? Okay. Because are you from the background of IT or are you pure engineering? Okay, very good. Okay, no problem. It's okay. I'm also from engineering background. Okay, now, if we see, right? Okay, all right. You are using fiber sensor. Okay, first thing that we do is that we must understand how the fiber works. All right. Just now I gave you in the earlier when I start my presentation, right? I've shared with you all. People never thought that fiber optic can be converted into sensor. Correct or not? In the first place. But knowing the characteristics of fiber, we first analyzed the characteristics of fiber and we studied that actually there is something called evanescent wave which can give the effect of sensitivity. Okay, so that is how we studied the behavior of the sensor in the first place and we understood how does the sensor work. Okay, now there are several, now we are moving into from the sensor behavior into several applications. So we are using sensors for medical field, we are using sensor for humidity monitoring in food, in agriculture, right? To study the presence of something that we want to measure. Okay, but as our sensor is becoming more and more complex, okay, and we believe that in certain situation, we cannot be at the site to monitor. Okay. So instead of having us to be there at the spot, we are replacing it with something called automated system. Okay. Now, when we talk about automated system, right, we have to use a system that is able to analyze. Okay. So now, what I'm trying to say here, our suggestion, the suggestion that I have here on for this presentation is that why don't we have machine learning incorporated with sensor? Okay, that was my idea. And I have done the review and I'm presenting here that yes, using machine learning, when you collect your data, okay, you are collecting your data, you are feeding the data to your machine learning model, you train your model, to provide output. Okay, now, when we talk about that particular model, it can come from any time. Okay, so whether this is the best or not is depends on what is going to be the output later. Okay, so we have to test it. We have to verify which method is the best. Okay, and how do we have this hybrid to come in? Also have to determine by us. So it is the report that we have to give upon trying this. So far I've never tried on hybrid yet, but I believe that you can come out with different models. You can do a comparison of the study, and you are the one who are going to report on this. So based on the suggestion that you have given, other researchers who are following will later on try this method and prove that yes, whatever Intan have said here is correct. Or they will even mention that no, I feel that this is better. So there's no right or wrong over here in research. You must understand that part. But we have to try it out and we have to prove with evidence that this is the right one. Okay. So keep trying in that. Maybe your research work might contribute to my findings that I've presented here. All right. I think I've answered that question in that. But keep in touch with me. Maybe we can work together. All right. Thank you so much.
Right. I think we can take one more question, the last questions before we will
Sure.
take the photo shoot section together. And also for all the participants, please fill out the attendance form so that we can also send the slides and sharing the video clips with you all. Yeah. So please fill up the attendance form so we can send you all the details of the seminar today. So the last questions, who would like to ask the last question before we take the photo shoot together? So if no further questions, then we will take the photo shoot together. So everyone is welcome to turn on your camera so that we can take the photo shoot together. Okay, please, if you have. Okay. So if you have your camera ready, can you just turn on your camera? Then we can take the photo shoot together. So I will screenshot from here. Right. Okay, just wait a moment. Let me take the screenshot. Okay. Okay, then the second page. Okay, wait a minute. Let me double check. Right, thank you very much. We would like to thanks Prof. Malathy and all the participants joining the PLS sections. I hope that everyone have a fruitful sections today about the SPR fiber sensor with the use of machine learning models to even improve the predictions and the results. So thank you very much. We hope that you all have filled out the attendance so that we can email the slides as well as also the paper that mentioned by Prof. Malathy, so that you all can also work with Prof. Malathy if you are interested in the topic of machine learning used in fiber optic sensor. Right, with that, I think our session today will be enjoyed here, and see you all in the future PLS sections. Thank you very much, everyone. Have a nice day. Goodbye.
Thank
Thanks, Prof.
you. Take care,
Malathy.
everyone. Thank you. Thank you. Thank you, Arnie.